Welcome to our lecture online. And the next set of videos is going to involve looking at optical instruments, and the simplest one is the magnifying glass. And let's find out how the magnifying glass works. Okay, so here we have an object that we look at without any optical instruments. It has a height h, and we place it 25 centimeters away from the observer, and so the angular size of the object is equal to theta. Theta is the angular size, meaning it'll be a ratio of the height to the distance of that particular object. Now what happens is, if we put a magnifying glass right there, then we're going to take the object and place it much closer to the observer, and in this case we're going to place it where the focal length is. And if you do that, you can look through the magnifying glass with what we call relaxed vision, and we'll find out in just a moment what that means. And of course that will then make a virtual image behind the object, and then the size of the image will then determine the angular size. And of course the angular size appears much bigger than it is over there, because the angular size theta prime is the ratio of the height of the image to the distance away to the image. So you can see that is a lot larger, which means then that the magnification of the magnifying glass is simply the ratio of theta prime over theta. Okay, now what is theta prime and theta equal to? Well, first of all, let's find the tangent of each of those. So we can say that the tangent of theta, by definition, is equal to the opposite side over the adjacent side. So in this case, that would be equal to h over 25 centimeters. The tangent of theta prime is equal to the opposite side over the adjacent side. That would be the height of the image divided by the distance to the image. Of course, we don't know what the height of the image is, we don't know what the distance to the image is, but what we can do instead is we can take a look at this triangle right here, and tangent theta prime would be equal to the height of the object divided by the distance here, which is equal to the focal length of the lens. So that would be equal to h over f. And then we can use the trick where for very small angles, the tangent of theta is approximately equal to theta, and the tangent of theta prime is approximately equal to theta prime, and for very small angles it's virtually exactly the same. We can then say that the magnification simply is equal to the ratios of those two quantities. In other words, theta prime is equal to h over f, and theta is equal to h divided by 25. Then you can see right away we can cancel out the h's. So then we end up with 1 over f divided by 1 over 25, which when we divide by fractions is the same as multiplying by its inverse. So this is equal to 1 over f times 25 over 1, or equal to 25 over f. So you can see right away here that the magnification of a magnifying glass is simply equal to 25 divided by the focal length. And in the case of this lens, let's say that this lens has a focal length equal to 10 centimeters. The magnification for this example, so if you take the example, f is equal to 10 centimeters, the magnification is equal to 25 centimeters over f, which is equal to 25 centimeters divided by 10 centimeters, which is equal to 2.5. So that means with a magnifying glass that has a focal length of 10 centimeters, you have a magnification of 2.5 if you look through the lens with relaxed vision. What that really means is that you're going to place the object at or just very near the focal point. And if s then is very close to f, and we go back over here and we realize that if we take the lens equation and we solve it for s, that means that s is equal to s prime f divided by s prime minus f. And you can see then that s prime minus f, if this is very close to 0, then the distance to the object, I'm sorry, I'm talking about the wrong equation here. If s is very close to f, then this is almost 0, and anything divided by 0 becomes infinite, which means that if you put the object very close to the focal point, the image will be formed very far away, and so you can look at the image with relaxed vision. Of course, what if you don't want to look at it with a relaxed vision? What if you want to look at it in such a way that the image is formed right here 25 centimeters away, so then you look at it with strained vision because then the image is much closer away, much closer. You can accomplish that by moving the object closer to the lens, meaning farther in from the focal point. So let's now move the object over there, so that now this is the object distance, which is now smaller than the focal length. And you can see then that the image that is formed by an object like that will now be larger. So the image will now be over here, which means you now have a larger theta prime. And so that makes it obvious then that when you bring the image in closer, you then look with strained vision, but you'll see a larger image, therefore you'll have a larger magnification. So where does the object then needs to be placed? Well, let's go over here and solve the equation for the object distance to accomplish that. And so what that means is we have S is equal to S prime F over S prime minus F. And of course, S prime is the 25 centimeters that the image will be at. Since it's in front of the lens, it will become a minus 25. Focal length is still 10, divided by minus 25, minus 10, or minus 250 over minus 35. And then if we grab a calculator, what is that equal to? So we have 250 divided by 35, and that would be 7.14, and that's equal to 7.14 centimeters. Which means, if you now take the object and you bring it in a little bit closer, so you have a larger image at a distance of 25 centimeters, you'll have to put the object at a distance of 7.14 centimeters in this particular case. All right, so in a more general sense, how do we find the magnification of a situation like that? All right, to do that, we then say that the magnification is equal to, and instead of using theta prime, we're going to use theta prime in red, which represents this new angle right here. And we then take that and divide that by theta, okay, the original theta. So what is theta prime equal to? Well, theta prime is equal to the object height, which is still h, but divided by a smaller s. So this is equal to h divided by s divided by theta, and theta still is h over 25. So h over 25. Now this s will become this quantity right here. So this is equal to h divided by the quantity s prime f over s prime minus f, all divided by h over 25. Okay, well right away we can see that the h's cancel out, and we can divide this by 1 over 25 is the same as multiplying times 25, so this becomes, well, 1 over this quantity, we can also invert that, so this is s prime minus f over s prime f. So that's simply taking 1 over this and inverting it. And then when I divide by this, it's the same as multiply times the inverse. So that's times 25 over 1. Okay. Now, S prime is 25 centimeters in this case. Actually, it's a minus 25 centimeters in this case. So this is going to be equal to minus 25 minus F over minus 25 times F times 25 over 1. And then you can see that this 25 cancels out this 25. And this minus will cancel out those two minuses. So then you end up with this is equal to 25 plus F over F. And finally, if I divide the F into the numerator, I can then say that the new magnification, which is equal to theta prime over theta, this is the new theta prime, is equal to, when I divide into that, I can say that's equal to 25 over F plus 1. And this is the magnification if we use strained vision. And of course, strained vision means that you're now going to move the object in a little bit closer in such a way that the image forms 25 centimeters away, which gives you a bigger magnification angle. And then this will then be the new equation to find the magnification. So in this particular case, the magnification would be 2.5 plus 1. So for the example that we have here, magnification would be equal to 3.5 for a lens with a focal length of 10 centimeters. And that's how you find the properties of magnifying glass and the magnification of a magnifying glass. Now, of course, once you've seen how that is done, you can simply say, if we look at it with relaxed vision, meaning if we place the object close to the focal point, the magnification will be 25 over f. If, however, we bring the object in a little bit closer so that the image now comes in at 25 centimeters distance, then the magnification will be 25 over f plus 1. And that's pretty well the only thing you have to remember if you try to find the magnification using a magnifying glass. And that's how you do that problem.